In calculus, when we talk about infinite limits, we're essentially talking about what you talked about in Algebra 2 typically is vertical asymptotes. And so just remember a vertical asymptote is where your function is going to positive or negative infinity as we're approaching some sort of x value. In calculus, we use the term of infinite limits to describe the behavior of the graph as it approaches this vertical asymptote. So is it going to positive infinity, negative infinity? Is it going to both? Is it only going to one? And so we talk about there's a vertical line where x is equal to a, and that vertical line is a vertical asymptote if the limit of f of x as x approaches a from the left is equal to positive and negative infinity, and or the limit as of f of x as x approaches a from the right is equal to positive or negative infinity. And so in order to find that vertical asymptote, first you want to make sure that there aren't any holes. So you want to make sure you don't have to cancel out any common factors, such as x plus 1 divided by x plus 1. The third part you need to do is you want to set your denominator equal to 0. You probably remember that from Algebra 2. And you want to find out what x values make the denominator equal to 0. And so when we talk about infinite limits, graphically, we're talking about an infinite limit goes up to positive infinity or down to negative infinity. That's what I mean by increases or decreases without bound. Analytically, we're actually going to find out what x value makes the 0 in the denominator, assuming that we're not canceling out any type of factors, and we're assuming that we don't get an indeterminate form. Remember, indeterminate, we learned, was when we had a 0 over 0. Numerically, what we're going to do, and I'll give you an example of this, is we're going to substitute a number approaching the limit to see what is the sign of the y value. If it's positive, if I yield a number really close to my vertical asymptote and it's positive, my y value is positive, that means I'm going up to positive infinity. If I substitute a number in really close to my vertical asymptote and it's negative, that means I'm decreasing to negative infinity. So let's look at number 1. We're going to try to find a vertical asymptote. Well, I hope you can see that even if I factor the numerator, I'm still not going to get some sort of factor that I can cancel out with the bottom. So I'm not even going to bother with that. But I do want to look to see where does my denominator equal to 0. Well, in this case, it's going to be x is equal to negative 5. And so that's where we're going to assume there's a vertical asymptote. And so we're going to go ahead and check from the right-hand side and left-hand side of our vertical asymptotes. And so I'm going to go ahead and write an L just to denote the left-hand side and an R to denote the right-hand side. And so I have the limit as x approaches negative 5 from the left. And I'm just going to go ahead and write my function 2x squared minus x divided by x plus 5. And I'm going to go ahead, I'm just going to kind of create a little bit of room on the side just to help you out. I'm going to pick a number really close to negative 5 that's on the left, but not quite. So if you want to think about, here's my number line. So let's think about it. What is a number that's really close to negative 5, but on the left-hand side? So I'm going to go ahead and say, I don't know, negative 5.01. So I'm going to go ahead and substitute in, this is what I mean by that third part where numerically substitute in negative 5.01. I'm not concerned about the actual value that I'm going to get. I'm more concerned about the sign. Is it going to be positive or negative? And so if I plug in negative 5.01, I'm going to get a positive number. So if into my x squared. So I have 2 times negative 5.01. So 2 times negative 5.01 minus negative 5.01 divided by negative 5.01 plus 5. Well, there's my squared. Sorry, forgot about that. So if I look at my numerator, I'm going to get, this is going to turn out to be a plus, this turns plus. And so if I square a negative, I'm going to get a positive. If I multiply by 2, I'm still going to get a positive. If I add another positive number, I still get a positive. So my numerator is essentially a positive number. Don't really care about the value, just care about the sign. In the denominator, I hope you see that if I add those two together, I'm going to get a negative number. Well, if that's true, that means I'm getting a negative y coordinate. Don't really care about the value, I just care about the sign. And so essentially what that tells me is since I'm getting a bunch of negative y values and they are decreasing consistently, that means I'm going down to negative infinity. Now let's check from the right hand side. And so the limit as x approaches negative 5 from the right, and it's going to write our function 2x squared minus x, over x plus 5. And so I'm going to do something very similar, except for I'm talking about on the right. And so I'm going to pick a number to the right. Well, I don't know, let's say negative 4.99. That's pretty, it's on the right hand side of negative 5, it's pretty darn close. And so I'm going to substitute that in. So I have 2 times negative 4.99 squared minus negative 4.99. And that's all divided by negative 4.99 plus 5. And again, if you look at the numerator, I'm just looking at just the sign. I don't care about the value. If I square a negative, I'm going to get a positive. So if I square this negative right here, I'm going to get a positive. And I multiply it by 2, I'm still going to get a positive. And if I add a negative, so that becomes essentially a plus plus. If I add another positive value, I have a positive number plus another positive number. And so a positive plus a positive is equal to a positive. So I have a positive numerator. So let's check the denominator. If I add 5 plus negative 4.99, I'm still going to get another positive number. So essentially a positive divided by positive yields a positive y value. And so again, I don't care about that value. I don't care about what number it is. I care about the sign. If I have positive y values, that means my function is constantly increasing or consistently increasing all the way up to positive infinity. And so just showing, well, essentially what these limits show in calculus is we have a vertical asymptote that exists at negative 5 because my function is increasing and decreasing on either side to positive and negative infinity. Alright, number 2, I'm going to go ahead and factor, and that's going to give me t plus 2, t minus 2, divided by t plus 2 times t plus 3. And as you can see, I have a whole, and so I'm left with t minus 2 and t plus 3. Well, that means my vertical asymptote isn't at t equals negative 2. My vertical asymptote is located at t is equal to negative 3. And so once again, I'm going to check the left hand side and the right hand side. And so I have the limit as t is approaching negative 3 from the left. And I'm just going to go ahead and write t minus 2, the simplified version, and t plus 3. And the right hand side, the limit of t is equal to negative 3 to the right of t minus 2 divided by t plus 3. And let's go ahead and think about numbers that are really close to negative 3 to the left. Well, I'm going to say negative 3.01. So if I plug in negative 3.01 into the numerator, I'm going to get negative 3 minus a 2. I'm still going to get a negative number. Don't really care about the value. If I plug in negative 3.01 plus 3, again, I'm going to get a negative number. Well, negative divided by negative is equal to a positive, so this is going to positive infinity. And so now let's try the right-hand side. So a number that's really close to negative 3 but on the right is negative 2.9. Well, if I plug in negative 2.9 into t, I get negative 2.9 minus 2, well, that gives me, again, a negative number. If I plug in negative 2.9 into the denominator, I have negative 2.9 plus 3, well, that yields a positive number. And so I have a negative divided by a positive, well, that's a negative, so that means my function is going to negative infinity. And once again, I have a vertical asymptote. I've proven a vertical asymptote using calculus that at t is equal to negative 3.